Hey everyone, I hope you're doing well today. In this video, let's talk about finding the surface area for some prisms and some pyramids. Specifically in this video, we're going to practice finding the surface area of prisms and pyramids. Now, how are you going to tell the difference between prisms and pyramids? Well, prisms are just going to have two bases. They always have some same shape on the bottom and the same shape on the top. And besides the two bases, the rest of the sides are going to be these things called rectangular faces, or all the sides besides the bases are going to be rectangles. So I'm going to write rectangular faces right here, and that's all the other sides. So you could have something like a square or rectangular prism. You could have a triangular prism. We have two triangles and a bunch of rectangles. You could have a trapezoidal prism, which is two trapezoids and the rest of the faces are all rectangles. You could have a hexagonal prism and so on and so forth. So while prisms have two bases, pyramids are only going to have one base, right? So think about how the Egyptian pyramids look, but they have, a square on the bottom, and that's going to be the one base. You could also have triangular pyramids or pentagonal pyramids or octagonal pyramids. That's just the base, the name of the base or the shape on the bottom is going to be that type of polygon. Now, while prisms have rectangular faces all around it that connect the bottom base to the top base, pyramids actually have triangular faces instead. So I'm going to write that down as triangular faces. And that means that all the sides besides the base are going to be triangles. And that needs to be true because pyramids have a point at the top instead of having another base. So in order for there to be a point at the top, you have to have a bunch of triangles that are going to meet at the top at just one point. So in this video, we're going to be focused on taking a look at prisms. So this is an example of a rectangular prism, just like this. And our goal is to flatten this out and draw a net for it. And so the focus in this video is going to be taking these prisms that look like this and basically just, cutting them and laying them flat. And if we lay them flat, all rectangular prisms are going to have 6 different types of rectangles or parallelograms that we can basically put together, and we can find the area of this 2D shape once we've flattened it. So this is called a net. Now let me see if I can draw a pyramid to the best of my ability. Hopefully you get the idea of what this is supposed to generally look like. These are kind of tricky to draw. So this is going to be a square pyramid. I know it doesn't look like a square on the bottom, but if you look at it from an angle, it should hopefully look a little bit more accurate to you. So this would be an example of what a square pyramid would look like. And drawing a net for this, our goal in this video is saying, how can we find the surface area of this thing? So if you lay it flat, you would have a square along the bottom, and then you would have these different faces, these different triangles that would meet at the tippy top or the point of it, and this would be the net for this square pyramid or rectangular pyramid. All right, so now that you just have a basic understanding of what we're doing today, which is really finding the area of all the surfaces of these 3D shapes, let's get into some practice problems. I encourage you to grab some paper, something to write with, and let's do some math together. So for example 1, we have a rectangular prism, and we're going to start by drawing a net. And so by doing so, maybe we'll start by just figuring out what the base or the bottom is, and that's going to be this rectangle that I'm kind of tracing over right over here to try to make it super clear. And so if I just go ahead and sketch a rectangle that's roughly 8 by 14, maybe something that looks like this, it would be 8 across and 14 back. And the top rectangle actually matches it, but we can't really draw that just yet. Let's go to one that's right next to it. So maybe this one over here, this is to the right side of it. Try to draw that the best I can. That's going to be this rectangle along the side, and that's going to be, what's that, 4 by 14. So let's go ahead and draw that right along the side here. This is 14 up and down, and 4 going across. And just keep in mind, if that's the same thing on the right side as it is on the left side, that's going to look something like this. Okay, so it's okay if it's not perfect. Just try to sketch it the best you can. And so that's going to be 14, and that's going to be by 4. And let's see what else kind of shapes we have here. So in the front, we have this height of 4, but it's going 8 across. So 4 by 8 is going to be the rectangle we have here. So we already know it's 8, and this is going to be roughly 4, or exactly 4. It's just mine's a little messy. 4 by 8. Okay, and then we have the same rectangle in the back here. So check out how I'm sketching that out here. And that is also going to be 4 by 8. Something like this, okay? So it looks like we've covered 5 of the sides, and the one that people forget about a lot is going to be the roof or the top of this shape, right? The bottom is going to match the top here. So that one, let's see, the bottom was 14 by 8, so this top is also going to be 14 by 8. So just something like that. That's going to be 14 by 8. Should be the same size. Okay, so let's now go ahead and find the area. Let's maybe start with the top and the bottom. So if we're going to find the area of the top and the bottom, let's see. Area is going to equal base times height. So we know the base is 8 and the height is 14, but there's going to be 2 of them. So we'll multiply that by 2. And so 8 times 14, I think that's going to be 112. And doubling 112, that should be 224 units squared, if I'm not mistaken. Okay, now I'll go for the greens now. The greens is going to be that top rectangle and this bottom rectangle, just like this. And so area is going to equal, what are the dimensions of the green rectangle? I think it's going to be 8 by 4, and there are 2 of them. Okay, 8 times 4 is 32, and doubling 32 is going to be 64. So that's both rectangles combined is 64. And then finally, let's go ahead with these yellow rectangles. And let's see, what are those dimensions of these yellow ones? I think they're going to be 14 by 4. So let's see and go ahead. Area is going to be equal to 4 by 14 or 14 by 4, and there are 2 of them. So 4 times 14 is 56, and 56 doubled is going to be 112 units squared. Okay, now if you're going to go ahead and just find the area of all of these together, then you're going to have to just add these 3 areas that we have from each of the surfaces, and by doing so, we should get a final surface area of 400 square units, or units squared. Okay, that would be the surface area of this rectangular prism. All right, example 2. We have another rectangular prism here, and in this problem, let's just start with the front. I generally try to start with one of the bigger shapes just to kind of get it out of the way. So we have a rectangle that's going to be 9 by 24. So let's go ahead and try and draw a net for this. So 9 by 24, maybe something that looks like this, and 9 would be the base, I guess, and the height would be 24. And what's going to be next to that? Or maybe below it. Let's do the base next, actually. The base is down here. That looks like it's going to be a square. Notice how it's 9 by 9. So let me go ahead and draw that square just like this. This is a 9 by 9 square. And actually, if we know that's 9 by 9, we actually know the top as well. This is also going to be 9 by 9. So we can go ahead and just draw that square up here. So it's 9 by 9. And let's go ahead with the sides now. So for the sides, I'll go on the left side. On the left side, we have this 9, and it has a height of 24. So we have a rectangle that's 9 by 24. So that's going to be 24 down, just like we had earlier. And it's got to match, so hopefully that does match up for us. So that's going to be 24 by 9. And we're going to have the same type of rectangle, exactly congruent, exactly the same on this other side. And that's going to be 9 by 24. I can write that a little neater, 9 by 24. And so it looks like we have the sides and the back. We need one more piece. We're missing one yellow rectangle here. So let me see if I can draw this without messing this up too much. This is in the back. 1, 2, 3, and the 4th side. Lots of colors going on here. So we need a fourth side to this. And then that way we have all 6 sides. So kind of like a tall building. And the 4 walls would be the green, yellow, and maybe the salmonish color. That 9 by 9 square is going to be the floor and the roof of this tall building. Okay, so go ahead and write that in. That's going to be the dimensions of 24 by 9. And I think we have everything we kind of need to go. So let's go ahead and find the area or surface area of this whole thing. So we have these 2 yellow pieces. I'm going to go ahead and find the area of those first. And so how's that going to work? That's going to be base times height, or 9 by 24, and there are 2 of them, so times 2. So let's see, what's 9 times 24? I think that's going to be 216, and 216 times 2 is going to be 432, 432 units squared. Okay, now while we're at it, we can go ahead and do these green ones. And notice how the green ones are the same as the yellow ones. So you could have just multiplied it by 4, but I'm just trying to be, very thorough with just kind of organizing everything. It's not always going to be a square, but you could technically just double the 432. You'll see right now why that's the case, right? We can just take this and multiply by 2. This is just going to be 432 units squared as well. So if you see that redundancy, perfectly fine. I just want to try to spell out everything as clearly as I can. This is going to be 9 by 9 for this square, and this is also 9 by 9. So the area is going to be 9 by 9, and there are 2 of these squares. So 81 times 2 is going to be, I think, what, 162 units squared. And we can then go ahead and just add up these areas together. So 432 plus 432 plus the 162 all added together. I think this total surface area should be 1,026 units squared. All right, so for example 3, we have a good old cube. Looks like all the dimensions here are going to be 13. So let's start with just the bottom here. So this is 13 by 13. So I'm just going to draw a square the best I can, looking something like this. And we'll label it as 13 by 13. And what's connected to this? Well, I don't know. Maybe we can do the front and the back. That's perfectly fine. The front here, this is also 13 by 13. So I'll put the front, I don't know, maybe right below it. And if that's going to be 13 by 13 also, then the back here, take a peek, this is going to be 13 by 13 as well. So cubes are kind of nice. So that 13, that's the back here. And the cubes are nice because you really just have to find the area of one of the sides, right? Because if you could find the area of one of the sides, then all of them are the same. So here, let's do the left side. That's also 13 by 13. All right, it's not the best drawing, but I think you get the point. And let's see, the right side looks like this. Let's see, looks good. Roughly. All right, let's see, we have our front and our back, we have our left and our right, we have our bottom, we just need the top here. So that's the only one we didn't do. Again, we should have 6 sides of a rectangular prism. And so for our lid or for our top, you really can choose where you want to put it. I feel like putting it down here. Feel free to put it in one of the other locations on the sides. That's going to be 13 by 13. Okay, so can we just find the area of one of these and then multiply that by 6? Absolutely, that's going to be the fastest way to do this problem. I know in the last problem I didn't do it that way, but maybe I can do that, or you can do that and see if you get the same answer as me and see how much faster that is, because it should be a lot faster. So for these 2 green ones, this will just be 13 by 13, and there are 2 of them, right? 13 by 13, and there are 2 of them. So let's see, 13 by 13, I know that's going to be 169. And then 169 times 2 should be 338 units squared, whatever those units are. And again, you can see the redundancy, hopefully. I just want to make this super clear. And so if you find this one, these 2 sides, the areas of them, it's also going to be 13. It's also going to be 13 by 13. And there are 2 of them, so times 2. This is also going to be 338. Okay, and then if we go ahead and do the sides here, which are these yellow squares, those are going to be 13 by 13 also. So could you just do, 169 times 6? That's fine. So this is 13 by 13 by 2, and that's also 338. And you could just triple 338, right? 338 times 3, because 6 of those, or 3 of these rather, 3 of the 338s or 6 of the 169s, that's going to be 1,014 units squared. There you go. That's a surface area of this cube. For example 4, we have this triangular prism here. So the bases are actually the triangles. It's in the front and the back. It's just kind of tilted on its side. You can think of this as maybe a ramp or maybe like a wedge of cheese or something like that. So let's go ahead and see if we can go ahead and draw this net out. So I'm going to start with the bottom or the base. Looks like we have a rectangle that is going to be 12 by 7. So go ahead and draw that out. And maybe I'll draw this one sideways here just to keep it consistent. So 12 by 7, maybe something that looks like this, 12 across and 7 up. Okay, now let's go ahead and try to draw these triangles that these little flaps kind of go on the side here. So looking at the side of a ramp, this would be this green triangle. Okay, and look, what are the dimensions of that? Well, it looks like we have, well, I'll just draw this on top here. This one would be in the back, I guess. And if we were to kind of see how tall this is, well, looking at our shape, looks like the height is 5, so I'll go ahead and draw that in here. So this will be 5. And besides the triangle in the front, while we're at it, I'm just going to go ahead and draw the triangle in the back. So notice how we have two matching triangles for this ramp, which is, we definitely want matching triangles or else this ramp will not be very even for you to go up or down. And so that would be like this triangle in the back, and that would be 5, okay, by 12. That would be the base and the height. And these are right triangles, as we can kind of see in the drawing, okay? And let's go ahead and do this rectangle that's along this back here, or at the top of the ramp, at the top of this prism. And what is that? That's going to be 7 by 5, okay? 7 by 5, that's going to be right over here, 5 over here, and 7 to the left of it, or to the right, same thing, okay? And what else do we have? Well, we have one final rectangle that's going to kind of be laid on top of this, and that's the actual part of the ramp. So if you were actually going to be walking on this thing or skateboarding or something along this rectangle, that's going to be this shape here, and this is going to have to lay on top of the ramp. So what's that going to be? Well, we know this is going to be 7 over here, and the length of it is actually going to be 13, because in the problem they tell us that the slant of the ramp is 13, and just keep in mind that those measurements need to match with each other. Okay, so we have a few different shapes here. This one takes a little bit more work just to kind of organize and understand. Okay, so let's start with here. For this shape in the middle, this is just one rectangle. And so to find the area of this rectangle, that's just going to say base times height, or 12 by 7. And there's only one of these, so 12 times 7 is 84. It's 84 units squared. Let's move on to maybe this rectangle on the side. I'm going to save the triangles for the last because I know they have a slightly different formula. And so for this triangle, that's going to say area is equal to, what is that, 5 by 7. There's only one of these. I'll write times 1. That's 35 units squared. Now I'll go over to this rectangle over here, which a lot of people think is the same as the base, but it's a little longer because it's along the slant or the hypotenuse of the ramp. And that is a rectangle, and it's 7 by 13, and there's one of these, so that's going to be 91 square units. And finally, let's take a look at these triangles. And don't forget, two triangles together make a rectangle, right, or a parallelogram. So for these two triangles together, this is where you have to pay a little bit more attention. It's going to be base times height divided by 2, right? So what's the base of that triangle? Well, that's going to be 12. It's going left to right, and the height of it is going to be 5, so base times height divided by 2. That's the area of the triangle right there. That's for one of the triangles, but there are two of them, so make sure we multiply that by 2. At this point, keep in mind that you can just cross-cancel these 2's. I know it's a little silly. We divided by 2, then we multiplied by 2, but technically that's what's happening, even though they disappear. And then 12 times 5 is going to be 60, so it's going to be 60 units squared, and that's for both triangles combined. Okay, now if we go ahead and add up all of these bits of area, all the area of the pieces, we kind of decompose this shape here, we should get a total of 270 units squared. That would be the area of this, or the surface area rather, of this triangular prism. All right, so here's example 5, and this seems to be a problem that kind of trips people up a little bit more based on how it's drawn and how it's laying. And so if this one gave you a little bit of trouble, I totally understand it. I'm going to try to sketch it in a slightly different way to kind of help you visualize it differently. So keep in mind that we have two dimensions of the triangle are the same, right? They're 10 and 10. So what if I go ahead and redraw a triangle and turn it on its side here and try to draw it in a slightly different way? And this is going to be the 14.1. And we'd have two of these triangles. So let me see if I can draw this somewhat accurately freehand here. Something that looks like this. And so we have two of those triangles, and then these are connected just like this. And so this would be the same shape that you see currently, just kind of turned on its side. So hopefully this is clear enough for you to see. This is also 14.1 along that diagonal. But this should hopefully help you with understanding the triangles that we really have here. Okay, so maybe if it helps, I'll start by drawing those triangles first. So let's kind of get rid of or work on the more challenging part, which is this measurement right here. Again, this is 10, and this is also 10. We see that from the bottom. And then this is going to be 14.1. So if I go ahead and draw that triangle maybe on top here, 10 and 10, and then this will be the 14.1. So I'll write 10 and 10 and 14.1. That will be our right triangle. Okay. That would also be, I guess, if I were to use this drawing down here, let's say that's this triangle in front, maybe. Okay. Now let's go over to maybe the base. So that will be 10 by 6. So I know it's kind of strange because I kind of flip-flopped it all over. So this right here is 10 by 6, and that's the same one as down here, 10 by 6. So we already know this is 10 going across, and so I want to come over 6. So let's see, 10 by 6. That's going to be the bottom. Okay. Now, if we know that's going to be the bottom and we have a triangle, we have another triangle down here. This is also 14.1, 10, and 10. It's kind of got that right angle right here. This is the same as the triangle in the back that I kind of sketched out over here. So here is this triangle roughly. This is our 10 and our 10 and our 14.1. So those are kind of the sides here, and we have just a little bit more to sketch out. So let's see here. We have a 10 by 6 rectangle connected over on the side here. So we know this is already 6. This has to just go out 10 to match the other side. So 6 by 10. And then we have one final shape to draw here. This one's a little bit harder to see, but this is 6 by 14.1. You guys see that along the slant there? Or it's the 6 by 14.1. It's all the way in the back if you're looking at this. Everything's kind of tilted on its side, so it's harder to tell. But here is the 6, and the 14.1 needs to line up with the slant along the triangle. So here is the 6, and here's the 14.1. So this would be the net for this shape. Hopefully that makes sense from beginning to end, how I kind of sketched that out, and it makes sense to you as well. Okay. And now let's go ahead and write out the work for finding the area. We got a bunch of different shapes here, so let's try to keep things organized. Firstly, let's maybe deal with this one. I think I've kind of used this color first, and that's going to be this rectangle right over here. And area would be 10 by 6, and there's only one of these, so that's going to be 60 units squared. Okay. Now let's go ahead. I'm going to avoid the decimals for a little bit. For this yellow one, that looks like it's just going to be 10 by 6. Oh, darn it. There's 2 of them. I should have just done 2. It's okay. It's not the end of the world. All right, just a little bit extra writing. All right, now for these decimals that I was avoiding a little bit earlier, this is going to be a rectangle that's 14.1 by 6, 14.1 times 6, and there's only one of these. I double checked that one this time. And if we were to go ahead and add up those areas, or just to multiply that area, that's going to be 84.6 units squared. Okay. Now let's move on to the triangles. So here we have a good thing we don't actually need the 14.1. We just need the 10 and the 10. So just like earlier, what's triangles? Triangles is going to be base times height divided by 2. So base times height, 10 times 10, divided by 2. That's the area of the triangle, but there are 2 of them. I got it this time. And we can cross cancel the 2's here. And we'll see that this will just simplify down to saying this is 100 units squared. Now each triangle is 50 square units, but combined the triangles make 100 square units. Okay, so if we were to go ahead and just add up each of these areas together, we will get a total area of 304.6 units squared. That would be the surface area of this triangular prism. All right, so for number 6, we have this tent-looking shape here. So let's go ahead and start with the floor of where you would typically sleep in this tent. And that would be these dimensions over here. So let's start by sketching out a rectangle. That's going to be 15 by 8. So 8 across, 15 back. And let's see what's connected to it. Well, we have this front triangle and back triangle. Maybe we can draw those out and sketch them. So we have this triangle going here. And those little markings just let us know that it is an isosceles triangle. So if this right side is 11, then this left side is also 11. That's all that's really saying. And it's connected to, I guess, the front of the tent. Maybe this will be the entrance to the tent, however you want to think about it. And so that would be coming down like this, okay, roughly like that. We know these are going to be 11, which will be helpful for other things, but it won't help us for the area of this triangle. Now, if you want to know the area of this triangle, Keep in mind that we are given that dimension, or that measurement rather, and keep in mind that in the drawing we are given the information as the height of that triangle. It's 10.2. It's drawn on the back triangle, but remember that these triangles are the same. They are congruent to each other. So this triangle in the back mirrors the triangle in the front. Otherwise, you're going to have a strange looking tent. And we can go ahead and label, sketch this out. It's a little bit tricky to draw, so do your best. I'm sure yours looks great. And that would be this shape here. Again, this is 11 on the slant, 11 on the slant, or the hypotenuse if you're looking at a right triangle. And this height here, which is going to be super helpful for finding the area of the triangle, that's 10.2. Okay. Now we've handled the kind of the front and back of the tent, but what about what's going to keep you dry, right? What's going to keep you dry if it rains is going to be these diagonal rectangles, or these rectangles that kind of meet, that are going to keep you nice and dry. So we know one side is going to be 15, that's right over here, and we need to know this is going to go out how far. This is just going to go 11, so 15 by 11, and that's why we needed to know the slant of the rectangle, or the slant of the triangle rather. And on the other side, I know this is a little bit tricky to see, but on the other side facing away from us, okay, you have the other rectangle. So I'll go ahead and draw that right over here. There you go, 15 by 11. All right, so more or less, this is what we're going to look like when we are putting this shape together. This would be a flattened version of the tent, or the net for it. And let's go ahead and find the area of each of these pieces. So right in the middle here, the area of the base is going to be 8 by 15. And how many of these are there? I think there's just one. So that's going to be 120 units squared. Okay. And if we move on to finding the area of maybe these other rectangles, I'm going to save the triangles for last. That's right over here and right over here. So the area is going to be 15 by 11, but there are two of these. So 15 by 11, I think that's 165. And doubling 165, that should be 330 units squared. Okay. Now we have a lot of information. We need to just keep on going on to these two triangles. We know the base is 8 for each of these triangles, and the height is 10.2. So we have two of them. So area is equal to base times height. That's going to be 8 times the 10.2 divided by 2. It's base times height divided by 2, but then we have to double it, so times 2. And keep in mind, I know these 2's will cancel out, which is kind of nice for us. Just go ahead and write that down. And 8 times 10.2, I think that's going to be 81.6, if I'm not mistaken. 81.6? That seems right to me. And if we go ahead and add up all of these areas, or the area of all the surfaces, which is why we call it surface area, then we're going to get a total area of 531.6 units squared, or square units. For number 7, this is where we have a pyramid. This is my best version of a square pyramid I could draw. So on the bottom of this pyramid, we have a square. You can see the little markings, and I wrote 8, 8, 8, and 8 as the sideline, so you know it is a square. You got to trust it, even if the drawing doesn't look as accurate as you may wish it to be or hope it would be. This right here is going to be our square, and I'll write 8, 8, 8, and 8 along each of the sides. And what's nice about pyramids is that once you have the base, every other side is just going to be the same triangle, right? That's how all pyramids work. So right over here, kind of sketch this out. This is a triangle. The base of it is going to be 8, and we need to know its slanted side. Do we know the slanted side? No, I don't think so. It's okay. We don't need it anyway, but we do know the height of the triangle. That's actually the important part, and that is going to be 12. So I'm going to go ahead and mark that down. So don't worry about the slants. We don't need it for this problem. And this measurement is going to be 12. And let's see why that's helpful. Well, let's go ahead and see if we can draw the rest of this out. And so along the side here, we'll draw this triangle, and draw this across. And let's see if I can draw the other ones while I'm at it. This one over here, going out and back. And on the bottom, let's see if I can draw another one, roughly the same size, something like that. Okay, so there we go. And each of these has the same height here, so we go ahead and label those. Don't worry about the accuracy too much, as long as you can tell where everything is. This height is going to be 12 over here. This one is also going to be 12, and this final one is also going to be 12. Okay, so we have 4 of the same triangles, so that should make our lives a little bit easier. So over here we have a square. This should be very straightforward. So the area is going to be 8 times 8, and then multiply that by 1. So it's going to be 64 units squared. Now let's deal with these triangles, and before we scribble it out, make sure we know the base is 8 and the height is 12. And so we have these 4 yellow triangles, and they are all just, the same triangle, just flipped upside down and turned sideways. And so we go ahead and say the area is going to be base times height, or 8 times 12, divided by 2. That's base times height divided by 2, but then it's times 4, since there are 4 of them. Right? And we can cross cancel if you'd like. We have a whole bunch of even numbers you can choose from. I'll just choose this one on the outside. So 2 and 4 make 1 and 2. 8 times 12 is going to be 96, and 96 times 2 is going to be, what is that, 192, I think. So 96 times 2, 192. I think that sounds right. 192 units squared. Okay, so there we have that. And so we have our 192 and we have our 64. And if we add up 192 and 64, that should be what, 256. I'm thinking 256 units squared. Cool. All right, that's number 7. All right, so take a look at number 8, which is also a square pyramid. So I'm just going to go ahead and draw and show you the base of it. That's this square over here. You can see the little tick marks. You can also see the 16 going all the way around. So we have all our measurements we need. So this is going to be a square, 16 by 16. So that's going to be right here, 16 and 16. That's our square. Now that we have the base down, remember for pyramids, besides the base, everything else is going to be a triangle. So here's one of those triangles. And I'm going to draw the one on top first, just so you guys can see it not being kind of flipped upside down and all. So the base of this triangle is 16, but the height of it is this 7.5. That's that measurement right over here. So I'll go ahead and label that as 7.5, but I won't necessarily go and label it on every side of this just because it's going to be a little redundant, but hopefully that is clear already. So here we have another one of these triangles, okay? I'll label the dotted line, but I'm not going to write in the numbers for it. So it's 16, and the height of this is also that 7.5. Then moving over to the bottom part, we have another one of these triangles, something like that. I'll draw where the 7.5 goes, and one final triangle. It's going to look something like this. All right, so there you go. There's our net for this this pyramid. So let's go ahead and see if we can find the surface area now. So I'll start with the square in the middle. This square we know is going to be 16 by 16. So area of that will be 16 times 16. It's a square, and there's only one of them. That'll be 256 units squared. And let's take a look at these triangles. Well, we have 16 going across the bottom, and we have a height of 7.5. So let's see here. The area is going to be 16, which is the base, times the 7.5, which is the height, divided by 2, because it's a triangle, base times height divided by 2, and then times 4, since there's 4 of these triangles. And while we're at it, let me just go ahead and shade in these other triangles as well, so we know which ones we're talking about here. And so then we can just multiply out and maybe cross cancel. This will be a 1 and a 2. 16 times 7.5, 16 times 7, and then half of 16. 120 times 2. I think this should be 240, so I'll put 240 units squared. And I think that's all the pieces we need here, right? So now that we have the area of the base and all 4 triangles together, we should be able to add up all of those together. And I'm thinking 496. That seems right. That would be the surface area of this pyramid. Alrighty, example 9. Here we don't have a square pyramid like the last two, but we have a triangular pyramid. So they're named by their bases again. So the base is a triangle, and then all the other faces are actually also triangles. So here we have an equilateral triangle along the bottom. So let me see if I can sketch one out that looks kind of similar to that. All right, good enough. I'm happy with it. That's a 6, 6, and another 6. Unlucky. And here we have a height of 5.2. So if you're wondering why they told you that, or if you're having trouble kind of seeing it on the figure, I'm kind of putting that there because, again, we need to know the base and the height of the triangle. So the 6's on the slants don't matter, but the 5.2 is important for finding the area of that triangle. And it looks like we have 3 of the same triangles sticking out of this space. So here's one of them. I'll choose this one since it has the correct dimension. So it has a height of 4, so slightly shorter triangle than the one going on the base. So here's one of those triangles, and this measurement is different from the other one. So I'll go ahead and just write that in, and that's going to be 4. And let's go ahead and just draw the other triangles in right now. So here we have another one. This one's congruent to it, has the same, and I'll go ahead. That's the height. That's going to be the 4. I'll put that here. That's 4, and then we have one more here. So this last one will go right over here, maybe. Okay, and this will also have a height of 4. All right, so more or less, that is going to be what our net will look like. And so if we go ahead and find out the area of this middle one, again, it's 6 by 5.2. I know I kind of covered up a little bit, but remember the original base was 6 all the way around. So let's go ahead and say this area is going to be base times height. So 6 times, we said 5.2 was the height of it. Base times height divided by 2. And there's only one of these, so I'm just going to write times 1. So we don't have to cross cancel. The 1's really not that important right now. And so if we multiply this out, I think this is going to be, what, 15.6? Should be 15.6, yeah. 15.6 units squared. And let's check out this triangle, which is, I think, what, 6 along the bottom, but 4 as the height. So 6 by 4, that's the base and height of these 3 triangles. And so we can write that out. It's going to be a base of 6, a height of 4, base times height divided by 2, and we have to multiply that by 3 since there's 3 of these. We can't cross cancel with a 3 without using decimal, so I'll cross cancel inside here. That's fine. We got some even numbers. 6 times 2 is 12. 12 times 3, that's going to be 36. So I'll go ahead and write 36 square units. And then we can just kind of go from there. 15.6 plus the 36. That total surface area should be 51.6 units squared. Cool. That would be the surface area of this triangle. And I forgot to kind of label these earlier or sketch these, but again, this is one of the triangles along the side. And even kind of weirder to kind of see is, another triangle in the back, maybe. I don't know if that's more or less confusing that I just drew it, but just to be thorough, that's where those triangles are. Finally, example 10 here, we have another triangular pyramid. And so I'll start with the base, which is at the bottom here. And we have another equilateral triangle. So every side's going to be 10 here. So based on the measurements of 10, 10, and 10, and the markings with the little tick marks, we know we have an equilateral triangle. So I'll go ahead and try to sketch one out that looks just like this. And we're also told here that the height of that triangle that's along the bottom is 8.7. So I'm going to go ahead and label that right here as 8.7. And what else can we do? Well, we have some triangles here, and so we'll try and sketch one out here. And this is going to be 10 across the bottom, which that makes sense. That matches that one. And the height is 17. Okay, so we don't know the slant, but that's okay. So it's 10. No, I kind of drew this one big. That's okay. 10 by 17. 17 is going to be right over here. Let's see if I can fit this. That's 17, okay? And then let's go ahead and draw another couple of these. So here's 10. Looks okay. And this is going to be 17. I'll write it upside down. And then we have one final triangle that matches the other two. Something like that. And this would also have a height of 17. All right, cool. So here we have a triangular pyramid, one final one. And let's go ahead and find the area of it. Well, the base is 10 for this one in the middle, and it has a height of 8.7. So let's make sure we use that information. So let's see here. The area is going to be base times height, which is 10 times 8.7 divided by 2, base times height divided by 2. And how many of these are there? Just one. So can we cross cancel? Sure, we can cross cancel these two numbers. That'll be a 5 and a 1. 5 times 8.7, that's going to be 43.5, I believe. 43.5. 43.5 units squared. And what about these other triangles? We know the base is 10 and the height is 17, so that's all we really need. 10 and 17 already. So we have area is equal to 10 base times height, which is 17, divided by 2 for a triangle, and times 3 because there are 3 of these triangles. Let's cross cancel this 2 and 10 to make 1 and 5. 5 times 17, I think that's 85. Yeah, 85, 85, then times 3, 240 plus 15, 255 is what I think it is. Let me think about that real quick. 255. I think that sounds right. Makes sense to me. Okay. And so let's go ahead and just add the area of the base with the 3 congruent triangles, and that should be 298.5 units squared. That would be the surface area of this triangular prism. And that wraps up this video on 10 different examples on finding the surface area of rectangular prisms, triangular prisms, square pyramids, and finally triangular pyramids. Hope it was helpful to just kind of sketch them out and draw the nets first and kind of break down the 3D shapes and flatten them into their 2D nets, and then just decompose them and find the area of each of the pieces, add up all those little areas to get the total surface area of the entire 3D shape. Whether it was a prism or a pyramid, that's the same strategy we can kind of use for all of these shapes right now. So hope you found this video helpful, and as always, keep up the great work, and I will see you in the next one.